Outcome 5 Calculator Test Relearn. 1 through 4 are all very similar problems, so I will go through 1 and 2 with you. On 1 through 4, what we're trying to do here is simplify. So I always like to start with finding the index. Number 1 doesn't have an index, so it's a nice little invisible 2. From here, we're going to take the number and start breaking it down. So 32 can break up into 16 and 2. 16 can break up into 4 and 4. And 4s can break up into 2s. Because the index is a 2, we're looking for groups of 2. I see one group of 2s and another group of 2s. And each of those groups will cross one of the 2s out. And that means that 2 2s are getting on the outside. Those 2 2s will multiply together, giving me 4. There was one 2 here that did not have a group, so this guy did not get out of the square root. So I'm going to leave a blank spot here and then put that 2 back inside the square root. Next, we'll look at our variables. So I have x to the 5th. Now, I will be trying to take my exponent and divide by the index, but 5 doesn't divide by 2. So what I like to do is rewrite this. And I'm going to take those 5 x's and just kind of pull 1 off to the side. So now I have 4 in one pile and 1 in another pile. This is nice because now I can divide 4 by 2, which gives me 2. So I have 2 x's on the outside, and this 1 x is left on the inside. When I look at my y to the 8th, 8 already divides by 2 nicely, giving me 4. So I have 4 y's on the outside. This right here is my final answer. Let's take a look at number 2. Number 2 is very similar, but the big difference is that now my index is a 4. Again, I'm going to start with taking 48 and breaking it down. 48 can break up into 16 and 3. 16 can break up into 4 and 4. And I'm going to break those 4s up even further. I'm looking for groups of 4, and I do see 4 2s here. I'm going to cross off 3 of those 2s, and 1 2 gets out. This 3 did not have a group, so I'm going to keep that 3 inside of the radical. I'm going to try and take my exponent and divide. So if I had 10, I could rewrite that as 9 and 1, just kind of pulling 1a into the other spot. That doesn't really help me a whole lot because 9 still does not divide by 4. So instead of 9 and 1, let's take 2 a's off to the side. That leaves me with 8. And this should work out nicer because 8 divided by 4 gives me 2. So there's 2 a's on the outside, and these 2 a's stay inside. b to the 9th, I'm trying to divide by 4. So if I took 1b off to the side, that would leave me with 8. Okay, 8 does divide by 4, giving me 2. So I have 2 b's on the outside and 1 b left over. Go ahead and try number 3 and 4. Here are the answers for 3 and 4. Go ahead and check my work and try to find your mistake if you got the problem wrong. Number 5 says simplify, and then it gives me 3 square roots that are all trying to be added or subtracted together. The big idea here is that I can't add and subtract square roots or radicals unless the stuff on the inside is the same, so that radicand needs to be the same. The first step that I need to do here is start with simplifying. So I'm going to take all the numbers on the inside of my square root and break them down. 32 can be broken up into 16 and 2. 16 can break up into 4 and 4. And since my index is just a 2, I'm going to stop here and group my 4's together. One of them crosses off. And then this other 4 is going to be jumping on the outside. There's already a 2 out there, so they're going to multiply together. 4 times 2 gives me 8. and this 2 didn't have a group, so it's left inside the radical. Moving on, I now have 80. I'm going to break up 80 into 8 and 10. 8 can break up into 4 and 2. I'm going to keep going because I don't see any groups yet. 4 can break up into 2 and 2, and 10 can break up into 5 and 2. I'm looking for groups of 2, which I see 2 groups. I cross 1 out from each, and that means that this 2 and this 2 are getting on the outside. So I have 2 times 2, which is 4, times negative 3, which gives me negative 12, and the 5 stays inside the square root. I'm just going to rewrite this so it's all in line. Alright, next I'm working with the 112. 112 I can break up into 56 and 2. 56 I can break up into 4 and 14. 4 can break up into 2 and 2. And 14 can break up into 7 and 2. Again, I'm looking for groups of 2, so I see a group here and here. Again, crossing out 1 from each. So I have 2 2's going outside. So 2 times 2 is 4, times the other 2 that was already out there gives me 8, and the 7 is left on the inside. From here, I want to look and see if I have like terms. 1 has a 2 on the inside, 5 on the inside, and 7 on the inside. None of those numbers are the same, so there's no like terms, so this is my final answer. Try number 6. Okay, if you got number 6 wrong, please take a minute to look over my work, pause the video, and try and find and fix your mistake. We'll take a look at number 7 next. Number 7 gives me 2 radicals, and I am multiplying. The big idea here is that things that are outside of the radical can multiply together, things that are inside the radical can multiply together. So we'll start with taking 2 times negative 3, both outside. That gives me negative 6. Inside, I have 8 times 4, which is 32. I'm now taking x to the 5th times x to the 7th. And what I'm really doing here is adding exponents, so I should have x to the 12th. I have 1y and 6y's, so 7y's in total. From here, I want to just simplify, so it kind of turns into the problems we saw in numbers 1 through 4. So I'm going to take 32 and start breaking it down. I could do 16 and 2. 16 breaks up into 4 and 4. I'm going to stop there because I see group. I can cross off the 4. This 4 goes on the outside. It's going to multiply with the negative 6, giving me negative 24. My index is a 2, so I'm trying to take my exponents and divide by 2. 12 divides by 2 nicely, giving me 6. 7 does not divide by 2 nicely, so I'm going to break it up into 6 and 1, because 6 divides by 2 and gives me 3. And I'm left with just 1y on the inside, along with this 2 here that did not have a group. Go ahead and try number 8. Here is the work for number 8. Go ahead and take a minute and check over to try and find your mistake. Number 9 says, do not solve. It just asks me to find the expression that is needed to rationalize the denominator. So in this problem here, we have 2 radicals that are being divided, and the big issue is that we cannot have a radical in the denominator. So what we need to do is figure out what we would multiply by to get rid of that radical. I'm going to start with breaking down anything I can. So it looks like 4 could break up into 2 and 2. Now, in order to escape from this radical, we would need groups of 4. We already have 2 2's. So to make a group of 4, we would need 2 more. So far, I'm thinking that I need the 4th root of 2 times 2. I also have 3 y's in the denominator. Again, I need a group of 4 in order to get out. so I only need one more y. Remember, with these, you're always focusing on that denominator, multiplying by whatever's missing in order to match that index. Go ahead and try number 10. Here's my work for number 10. All right, number 11, I think it looks very similar to 9 and 10, but the big difference on this guy is that our indexes are different. So I see an index of 3 and an index of 5. If you see something that's dividing and you have two different indexes, you want to change forms. So we're going to change this out of radical form into exponential. So coming from the top, there's a 3 on the inside, so my base is going to be a 3. And then I need to think about what that fractional exponent should look like. Whatever number is outside becomes your denominator, and whatever exponent was inside would become your numerator. There's only one 3 here, so this becomes 1/3. Do the same thing to the bottom, so again, 3 is my base. There's now a 5 on the outside, so 5 becomes my denominator, and the exponent is 1. Now that I'm dividing and I have the same base, I am going to subtract my exponents. So the base stays the same, and I'm going to do 1/3 minus 1/5. I'm going to use my calculator from here to type in 1/3 minus 1/5. It gives me this fraction, or this decimal, and I don't want a decimal, I want a fraction. So I'm going to go to math, enter for frac, and it gives me 2/15. I always want to make sure that my answer matches my problem. Because my problem started with square roots, my answer should also have a square root. So I'm going to change this back into radical form. The denominator becomes my index, and 3 squared will stay on the inside. The last thing that I can do here is reduce. 3 squared is the same thing as 9. Go ahead and take a minute to try number 12. Here's the work for number 12. If you got it wrong, go ahead and check back, try to find your mistake. Okay, number 13 is next. With number 13, it gives me x to the negative 10th time, or to the exponent of 2/5. When I have exponents like this right next to each other, it's a power to a power. My exponent rule says that we should multiply them together. I'm just going to use my calculator here to make it nice and easy. So I'm going to type in negative 10 times 2/5, and it gives me a negative 4. So now I have x to the negative 4th. Now I know that with my exponent rules, I'm not allowed to have a negative exponent, so I'm going to change this into a fraction to get rid of it. X to the 4th goes on the bottom, and the negative becomes positive. Nothing's on top, so it's just a 1. This right here is my final answer. Go ahead and try number 14. Right, number 15 gives me 5, 3x minus 4, with an exponent of 1/3 equals 10. Now these are very similar to solving with square roots. The first thing that we want to do is get this fraction exponent by itself. So I need to move the 5 to the other side. Because the 5 is right outside of parentheses, to move it over, we will divide. So I'm left with 3x minus 4. Still have that exponent of 1/3. But now I have 10 divided by 5, which is 2. In order to get rid of the 1/3, we're actually going to use another exponent. So I'm going to put an exponent of 3 on this side. If I do that to one side, I have to make sure I do it to the other side. I know that seems weird, but what happens here is the 3 and the 1/3 cancel out, leaving you with 3x minus 4. 2 to the 3rd power, you might know, you might need to use your calculator. Remember that if you need to use that exponent, it's this little caret button here. 2 to the 3rd gives me 8. And now I'm solving for x. So I'm going to add that 4 to the other side. So 3x equals 12, dividing by 3, and x equals 4. I also need to make sure that I'm checking my answer. To check my answer, I'm going to take this 4 and plug it back into my original. So I have 5, 3 times 4 minus 4 to the 1/3 equals 10. So I'm going to use my calculator, and I'm going to type in just the stuff on the left-hand side of my equal sign and hope that it equals 10. So I have 5, parenthesis, 3, parenthesis, 4, minus 4, an exponent of 1/3, and it gives me 10. 10 does equal 10, so that means this is a correct answer. Go ahead and try number 16. Here's the work for number 16. Feel free to pause and check over your answer. The last one that we'll do together is number 17. Number 17 says list all possible solutions using an inequality that satisfies the following inequality. So very similarly, we're going to start with solving this entire equation. So I'm trying to get the radical by itself. I'll subtract 1. I'm left with square root of 5x minus 4 is less than or equal to 6. To get rid of the square root, we will square both sides. The square and the square root cancel, leaving me with 5x minus 4 less than or equal to 36. From here, I'm going to add 4, and I have 5x is less than or equal to 40. Dividing by 5 gives me x is less than or equal to 8. Now this is half of my answer. In order to check this time, we are not going to plug back in. Instead, what we're going to do is take whatever is inside of the square root, so just the inside of the square root, 5x minus 4, and set it greater than or equal to 0. This is always greater than or equal to 0. What we're doing here is making sure that we don't have any imaginary numbers. Imaginary numbers come from when the inside of your radical was negative. So we're going to go ahead and solve this one. I'm adding 4 over, so I have 5x is greater than or equal to 4, dividing by 5, and x is greater than or equal to 4/5. From here, I'm going to make a number line to compare my two answers. I need to make sure that the smaller number goes on the left, so 4/5 is smaller than 8. Since x is less than or equal to 8, we're going to have a closed circle here. Closed circle because it's or equal to, there's that bar underneath. And I want less than, so that means I'm going to be shading everything to the left. I needed x to be greater than or equal to 4/5, so I would have a closed circle on 4/5, and greater than means I would be shading to the right. My final answer is where it was double shaded, which is in between the 4/5 and the 8. The way that I remember this is I just put the x right in the middle, and we fill it in with less than signs. This is called a compound inequality. This compound inequality is my final answer. Go ahead and try number 18. Here is the work for number 18.